All right, section 1.3, simple random sampling. This is a big deal in statistics. So, in true chapter 1 format, we're going to do a bunch of definitions. So, chapter 1 is going to set the stage for everything else that we're looking at. So, yes, it gets a little tedious with all of these definitions, but hang in there. You're going to see them come up again, especially random sampling. So, here we are. Random sampling is the process of using chance to select individuals from a population to be included in the sample. So this is literally random, and that's the whole concept of chance, right? So random sampling is the chance associated with that. So using chance or something that's random, right? I don't know how else to say that. A sample size of n, notice that this is a lowercase n. That's important. So a sample goes with lowercase n, and a population goes with capital N. Makes sense, right? Population is everything. Sample is a subset of that. So it makes sense how that works. That's important. When you see lowercase n, you know that's a sample. When you see the uppercase N, you know that's a population, and that's always in terms of sample size. Variables are important also. Okay, so a sample size n from the population of size n, lower and upper, we already talked about that, is obtained through simple random sampling if every possible sample size has an equally likely chance. Equally likely chance of occurring. The sample is then called a simple random sample. There it is. So the sample, remember we've already talked about that. That was in 1.1. A population, a sample, it's coming back, and it's coming back already. Those words are important. Those definitions are important. So here we are, a simple random sample, but here's the key to this one, which is why I had us fill in those words. There is an equally likely chance for all of the subset here, these samples, to happen. All right, so check this out. I'm going to scoot this up. Illustrating a simple random sample, Sophia has 4 tickets to a concert. 6 of her friends, Yolanda, Michael, Kevin, Marissa, Annie, and Katie, have all expressed an interest in going to the concert. Sophia decides to randomly select 3 of her 6 friends to attend the concert because 4 tickets, one's for Sophia, so she's got 3 extra tickets, right? That's where that's coming from. Then she's going to list all possible sample sizes. Everybody is equally likely. So sample size 3 from population 6 because she has 6 friends. Once an individual is chosen, he or she cannot be chosen again. So whenever you're going through this, you're setting this up. Now I put this table in here so we didn't have to write it all out, but I'm just going to show you what's happening. So Yolanda, right? So here's our first one. This is how you work these sample sizes out. You got Yolanda, and then Yolanda, Michael, Yolanda, Kevin. Yolanda, Michael, Kevin. Yolanda, Michael, Marissa. See how that is? Yolanda, Michael, Annie. Yolanda, Michael, Katie. Do you see where that happened? Then Yolanda and Michael have had every possible scenario. So I'm going to take Yolanda and Kevin and put her with Marissa. Do you see how that played out? Then Yolanda and Kevin with Annie. Yolanda and Kevin, right, with Katie. And that's how this is done. And then we've taken care of Michael. We've taken care of Kevin. Now Yolanda with Marissa and Annie. And then Marissa and Katie. Then Yolanda with Annie and Katie. Now that's all of those that can happen with Yolanda because she's taken out. Okay, now Michael can be with Kevin and Marissa. And Michael and Kevin and Annie, Michael and Kevin and Katie. Do you see how this is? If you do this systematic, then it makes it easier. And then Michael is with Marissa and Annie and Katie. And then Michael is with Annie and Katie, right? Michael's with Marissa and Katie. Michael's with Annie and Katie. And then once Michael's all taken care of, then we look at Kevin. Kevin with Marissa and Annie. Kevin with Marissa and Katie. And then we're out. And then Kevin is now with Annie and Katie. And then lastly, Marissa, Annie, and Katie. And these are the last three, so that's my last scenario. Do you see how that played out? Now, it doesn't matter the order they're in. We only put them in this order, so that works out. If I choose Katie and Marissa and Yolanda, well, if I'm looking at that one, Katie, Marissa, and Yolanda. Yolanda, Marissa, and Katie. It doesn't matter who I chose first, right? It's the three people, and those three people are that category. It doesn't matter who gets chosen first. Okay, so the order doesn't matter, and that's the key to this. Okay, cool. So how many do we have? 1, 2, 3, 4, 5. 1, 2, 3, 4. So we have a total here of 20 options, right? Because 5 times 4 gets the whole group. Now we want to know what's the likelihood that Michael, Kevin, and Marissa are going to be chosen. Where are Michael, Kevin, and Marissa, meaning all three together, not individually, but all three, Michael, Kevin, and Marissa? How many options are we going to have for that one? There they are. Let me do this with a highlighter because you can see it better. Is there any other time that Michael, Kevin, and Marissa are going to be chosen? No, not those three individual, because I can only have those one time. They can't be doubled up. Now, individually, they can all go with different people, but the only opportunity I have for Michael, Kevin, and Marissa all to be happening is 1 in 20 chance. Right? So there's a 1 in 20 chance because there's 20 total possibility and only one time that can happen. All right. Yeah, so everybody has the same opportunity, right? You can be chosen several times because you just go with a bunch of different people. So hopefully all 6 of these friends get along with Sophia and themselves, because you never know who you're going to go with. So hopefully they're out there having a good time. All right. So that's how that all plays, if we're looking at that. And you are going to be asked to come up with this. That's kind of why I wanted to go through that process. So whenever you have to do it in your homework, then you can do that. All right. And then one more definition here that we're looking at on this page. Frame is another vocab word. It's a list of all individuals within the population. That's a frame. All right. So if we want to number individuals out of everybody, like everybody that's possible, we want to number them. That is called a frame. It's a list of all individuals within that population. All right. Okay.